Hello, welcome back to the channel. We continue to review the textbook, Understanding Construction Drawings. This video is about Unit 21, and that is roof trusses. So unless a building is a simple square or rectangle, there are probably several types of trusses that are used in the roof. And we will take a look at a few trusses here, and we will find information about trusses on plans, elevations, and sections. And we'll be able to identify the appropriate truss engineering drawing for each truss in the roof frame. And also we'll take a look at the engineering drawings, and we'll be able to find the key information there. So the roof is designed to support weight, withstand weather, and give protection to the spaces below it. And in most roofs, the frame is made up primarily of trusses. However, some special framing situations call for rafters. Designing trusses to withstand all the stresses that can be placed on them by wind or snow or both requires the skills of an engineer. An architect or designer who designs the house has some idea what size and type of trusses will be required, but for the most part, it is the structural engineer who actually designs that and calculates the load. The pitch of the roof can be seen in the building elevations, and section views through the building show trusses, but the truss shown in a section might not be the truss that the engineer designed. So again, as always, I would like to redirect you to the textbook and actually take a look at the drawings, at all the graphics there, because that is important to understand how that is graphically represented. So also the section diagrams list the other components and length of the construction. For example, rafters, beams, ceiling joists, concrete slabs, interior studs, vapor barrier, and insulation spaces. And you can see that all in the drawings. So when we talk about truss engineering drawings, um, the delivery sheet is showing all the types of trusses that are used in the building. And this sheet usually shows the following information. Profile, that's a small drawing showing the basic shape of the truss, the basic type. Quantity, number of each type of truss needed for the building. Then truss ID, the engineer's letters or numbers, and basically the designation for that truss type. Span, the distance between the outside walls the truss will cover. Then the truss type, some trusses are referred to as piggyback trusses, and large trusses can be too large to transport to the construction site, so they are delivered in two parts. The top of the main truss is flat, so the piggyback truss can be applied to it after it is in place. And again, you can see all the details here. Then another information that is listed on the sheet is slope or pitch. And also you can see the unit rise of the roof or the slope. And then LOH, which is left overhang, the amount of the top core that must extend beyond the building wall, and ROH, or right overhang, the amount of the top core that must extend beyond the building wall, so like on left and right side. Please take a look again at the textbooks, the graphics here. So you can see the truss delivery list. You don't have to memorize it, but it's, it's always good to know the shapes of the trusses. So you can see the piggyback, you can see gable, you can see common, you can see like mono pitch and like valley and other types here. So please refer to the textbook. So as far as the span, that's the distance between the outside walls, and I already covered that. So please remember that. Also, usually the packet of engineering drawings includes a truss layout plan. Excuse me. And this plan shows the position of each truss on the building with a label to indicate the truss ID. So and if you know from where in the building this section view is taken, you'll easily find the truss layout. So please refer to the drawings, and when you are in the field, when you are looking at the drawing, so it will be easier to identify them with the truss IDs. Also, there are figures showing the truss plan. There are floor plans and also the engineering detail. So what that actually is, that are the detailed drawings for each type of truss. And the truss detail includes a drawing of the truss and all the engineering data required to build the truss. So another drawing is the guide to truss engineering symbols and numbering. So they'll be provided by the manufacturer. We are moving to the next sub-chapter, that's gable ends. And a roof gable is, we remember that is a triangle formed at the end of the roof by the two top chords of the truss and its bottom chord. The roof framing at a gable end must include studs. So there will be a place to attach whatever sheathing and siding are to be applied. And the gable end truss is used for this. So where an overhang is needed on the gable end, it can be built as part of the gable end truss. And again, please refer to the textbook. So that was it for our Unit 21. Thank you so much for watching. I will see you in Unit 22.